Thank you. Yes, this is the first time I'm going to do this talk. This is also the most complicated topic I've ever tried to wrap my head around. Before we go any further, if I'm talking about the visual viewports and density-independent pixels, who has some clue what I'm talking about? Oh, quite a few, and that's good. This is the very first time I'm going to do this presentation, ever. In fact, I finished the slides at 2:30 this afternoon. I had to run here for some meetings. So I have no clue how it's going to go. I am still trying to get a feeling for how an audience wants this complicated topic to be explained. And I think I'll just start and we'll see where we go. And if you really don't follow it anymore, let me know after. And I'll probably make some changes to this presentation. And I have to turn on my presenter, and there we go. As an example site, I'm going to use the site of my conference in Amsterdam, mobilism.nl, because it's the responsive web design I know best. You can follow along if you want. You can use it either on your laptop or on your mobile or on your tablet. Of course, it's a proper responsive design that works absolutely everywhere. But for most of this presentation, I'm going to assume that there is actually no responsive design here, and that we're actually looking at a simple desktop-optimized web page that is suddenly shown on a mobile device. Because that's the main point I'm going to make here. When Apple started the iPhone, and even before that, when Nokia became serious about web browsing, they knew that their mobile browser on this tiny device had to be able to show desktop sites made by people who didn't even know about mobile and who certainly hadn't optimized their site. So a lot of decisions they made hinged on that. A normal desktop site without any mobile component must also work fairly decently on a mobile device. Okay, so what are we going to treat today? We're going to start with the three kind of pixels we're having. We're going to continue with the two viewports we have on mobile. Then we'll talk a little bit about zooming, and especially how it's totally different on desktop and on mobile. Then we're going to talk about how to access all this kind of information with JavaScript, which is basically 5 property pairs, and they are already on my site. They've been there for 2 years, but I'm going to treat them anyway. And finally, we're going to talk about media queries and about the meta viewport. Who here has heard of the meta viewport? Most people, not everybody. Interesting. Okay. So, pixels. What's a pixel? The W3C says that a pixel, and I cannot quote it because it's a too complicated definition, it has something to do with the angle of sight, right? A pixel is a certain amount of degrees in your angle of sight, which basically means that a pixel on a phone is much closer to your face and should be slightly larger on a desktop and slightly larger on a TV. This definition comes from back in 2000 when W3C had no clue what it was doing. It is completely unusable on mobile, I'm afraid, because if you think about it, suppose you have a definition of a pixel that says, okay, it has to have a certain angle in your sight. That means that you cannot zoom, because then the pixel would grow, and that's not allowed, because then it becomes larger than the allowed angle. So the specification gives us no clue whatsoever what's going on. Basically, we have to distinguish 3 kinds of pixels: the CSS pixels, density-independent pixels, and device pixels. And I'm going to explain all 3 to you. We'll start with CSS pixels. Basically, CSS pixels is what you use in your daily job, right? If you say this element has a width of 190 pixels, or a padding left of 20 pixels, or whatever, then you are talking about CSS pixels. And you use it normally, naturally, without thinking about it, and that's good. Again, because we have been using this for ages and ages on desktop, it must also properly work on mobile. But there are several catches on mobile. But remember this, if you're ever in doubt, CSS pixels are what you want. And the point here is that CSS pixels are not in any way related to true device pixels. That is, to the true physical pixels that are present on your device. They're an abstraction layer, because the size of a CSS pixel may be increased or decreased, for instance, by zooming. Here's the site. This menu has a width of 190 pixels. That's how we defined it in the CSS. What happens when we zoom in on that side? It's still 190 pixels, but each and every pixel is slightly larger. That's what I mean by CSS pixels. CSS pixels can grow and shrink according to the way the user's zooming right now. Now, on desktop, we kind of take that for granted, right? On desktop, we say, yeah, the user zooms, which means everything becomes bigger. And that's exactly what needs to happen, because usually users zoom because they can't read the text too well and need a slightly larger font, right? Basic accessibility. So that's CSS pixels. Device pixels are basically the actual physical pixels present on your device. Basically, you can't change anything about it. As soon as you buy a device, it has a certain amount of pixels horizontally and vertically, and there's nothing you can change about that. I'm going to explain this part on the iPhone. We all know that the old iPhone, the iPhone 3G, I still have one here in my pocket, I still use it 4 years after it was released. It had a width of 320 pixels, which has kind of become the magic touchstone of all mobile web development because the iPhone is so very popular. So we all know that. We make sure that our website works properly on the iPhone, etc., etc. But oh, wait a minute. This is the meta viewport. I will explain it in detail later. I'm going to just briefly go into something. I'm saying here a device width. What is this device width? It's basically the number of device pixels on the device. This construct is used in order to make sure that your site is narrow enough to be shown pleasantly on the device. And in the case of the iPhone, that means it has to be 320 pixels wide, but I've also seen phones that work better with a 240, etc., etc. In any case, up until 2 years ago or so, this was directly related to the number of device pixels. So on the iPhone, your site is restricted to 320 pixels. However, then came the Retina display. Basically, this is part of a trend. Apple's take on it is most visible, but we're seeing device vendors cramming more and more pixels into the same space because it just gives a nicer display, a better display. In theory, now you would say, okay, so the iPhone, which was the first one, iPhone 4, I think, has more pixels, twice as many, in fact. So the meta viewport width, the natural viewport width that's given by device width, should also double. Point is here, that would break sites, right? First we had only desktop. Then Apple came along and said, okay, in order to make a proper mobile site for the iPhone, you have to use basically the meta viewport I showed you just now, which restricts your site to 320 pixels. If Apple would suddenly double that to 640 pixels, then many sites would break. And both developers and consumers would become angry at Apple. So that was absolutely impossible to do. So we have a new iPhone with 640 actual pixels, physical pixels on the screen, but we still want to restrict our websites to 320 pixels. And that's where the density-independent pixels come in. Basically, Apple said, okay, we are going to pretend, for the web developer's sake, that our screen is still 320 pixels wide. And basically what they created was another abstraction layer. Density-independent pixels have nothing to do anymore with physical pixels. They are yet another abstraction layer in between the actual physical device pixels and the CSS pixels that we work with every day. Okay, this is a very complicated definition. It's the best I could come up with. And basically it comes down to, for the iPhone itself, 320 pixels. What we have to see here is that this was a necessity. We as web developers do not want to be confronted with the true breadth and width of the immense amount of devices we have around the world and the actual physical pixel count, because we would go absolutely crazy. So that's why a lot of vendors right now are implementing density-independent pixels, which basically say, okay, you have CSS pixels that you work with. If you absolutely have to know more about the device, we will refer you to this intermediate layer, which will give you a reasonable answer that you can actually use in your daily work. It all sounds very complicated, and frankly, it is pretty complicated. So, the definition of this device width has just changed slightly because it now means the number of dips and no more the number of device pixels. So no more physical pixels, we add an extra abstraction layer because we must. In practice, on the iPhone, and of course what Apple wanted, your site is still restricted to 320 pixels, which means in practice that on an iPhone 4G or higher, one device-independent pixels covers 4 actual device pixels, right? 2 times 2. And this will continue. If Apple creates a Super Retina display or so with even more pixels, the device-independent pixels will remain constant at 320. So with all these kinds of pixels in mind, what do we actually need as web developers? I already gave you a clue. CSS pixels are by far the most important part for us. We have to work in CSS pixels. I'm going to explain a little bit more about how they work. But basically, you have to keep in mind the idea of a pixel that's initially this wide, but it can grow and it can shrink, and your entire website will grow or shrink with it. Density-independent pixels are kind of important because they figure in the meta viewport, but you don't really have to think about them. Device pixels, finally, are totally and completely unimportant to us. Well, except, of course, with the latest fashion, now that the iPad 3 is out, of creating super high-density graphics for the iPad 3 because it has such a high-density display. From a design perspective, that's, of course, wonderful, but I'm a bit worried about the networking side of things. I mean, I have an iPad, I have a 3G connection, and I want to load just a random site because I'm on the train and board, whatever. And that site sees I have an iPad 3 and sends me images that are basically 4 times as large as the normal images, right? 2 times 2. What is that going to do to our mobile connections? My problem here is that the Retina display is, as far as I can see, the absolute vindication of Moore's law, because components are getting cheaper, and it was very clear from the outset that Apple was waiting until the moment in time they could sell these components in the iPad 3 for a market-conform price. But Moore's law does not go for mobile connections. Mobile connections are dependent on things like cell towers and spectrum questions and bandwidth questions that are not truly influenced by Moore's law. So basically what we're seeing here, displays are getting even more finer and finer, and in the end it will mean that the graphics will be so immensely huge that we cannot download them at all over a mobile connection yet. I don't know what the solution is here. I'm just saying that there might be a problem here that we have to think about. Okay, so what kind of pixels do you encounter in practice? As I said, in CSS, everything is CSS pixels. That's really simple. In JavaScript, in those JavaScript properties that are expressed in pixels, most of those properties are actually also CSS pixels, because that's what we need to know as web developers, right? We are not interested in how many actual physical device pixels is this div spanning. We want to know just the offset width of the div, and that is in CSS pixels. There are a few exceptions to this rule, the most important one of which I'll treat later on. Sometimes it's device pixels or dips. I mean, we've already seen an example of that, the meta viewport with device width, right? It used to work with device pixels and now works with dips. Okay, I'm hoping I haven't confused you yet, because we're going to go deeper. This was just a kind of a gentle introduction to the problem, and also because I actually needed to define CSS and device pixels and dips. Viewports. What is a viewport? Basically, the viewport is a total amount of space you have available for your CSS layout. And we all know instinctively on the desktop that means the browser window, right? If we do nothing special, our elements, our divs and Ps and our body and our HTML are going to span exactly 100% of the browser window. And we've internalized that message and we count on it intuitively. And this is going to be a problem on mobile because on mobile it's different. On the desktop, though, the HTML element has an implicit width of 100%, right? It's a block level element, and any block level element has an implicit width of 100%, which means it spans the entire viewport, which means it spans the entire. So here we have the site again. What is the viewport? Simply this. Nothing surprising. We've worked with this fact for years. If we give anything a percentual width, this, for instance, has a padding width of 34%. 34% of what? Of the browser window. We all know that and we'll all count on it, but it doesn't always work that way on mobile. Because on mobile, stuff is a lot more complicated. Basically, because the screen is so very narrow on most mobile devices, our carefully crafted layouts would break horribly. And remember, a mobile browser must show all websites properly, even if it's only for desktop, even if the developer has done nothing about mobile. That's what Apple wanted to achieve, and it has basically achieved that with the bag of tricks I'm going to talk about now. So, our website has a two-column layout, and the designer has decided to implement that by giving the main content block a padding left of 34%. And this is all positioned absolutely, right? It's one of the many choices you can make in order to create this layout. Now, on a desktop browser, this works absolutely fine. You can kind of gently flow with the exact screen size, and if you change the width of the browser window, this will remain roughly 1/3 of the browser window, and well, it's all liquid design. We've known this for years, and it works absolutely fine. Now, suppose we are going to show this site on a mobile browser, and neither the developer nor the browser vendor has done anything whatsoever. We get this, and this is not what we want. Padding left 34%, sure. Browser takes you literally and says, okay, 1/3 of the screen is basically empty, and it's reserved for this column. But here we still have a 190 pixels absolute width. And of course, there is going to be huge overlap. This is exactly the thing that Apple wanted to avoid when implementing its browser. This is exactly what we have to be afraid of on mobile, because it's just different. We have to think differently. We have learned to think differently over the past 2 years. But I think we should understand a little better what we're talking about. So that's why I'm here, that's why I'm giving this talk. In any case, this does not work. I hope you will agree with me. So what did the mobile browser vendors do? They basically split the viewport concepts into two. We have the layout viewport, and that is the viewport that we use for CSS, such as the padding left 34% we saw just now. If there's a padding left 34%, we say that's 34% of the layout viewport, which is not necessarily equal to the screen size. So basically, this is what most mobile browsers do when they encounter a purely desktop website. Once you've zoomed in to a proper level, you get something like this. Only part of the site is visible in the screen of the phone, and the rest is off screen. You can of course scroll and zoom and do whatever you like. But the point here is that they take a so-called layout viewport, which is like somewhere between 800 and 1,000 pixels. It's an internal definition of the browser. If we don't quite know what's going on, then we're going to say, okay, the root of our CSS, basically the width of our HTML element, is going to be somewhere between 800 and 1,000. The iPhone says 960. I found a lot of difference between the various Android devices, not surprisingly. And the other browsers stay roughly in that neighborhood. So this is the layout viewport, and it basically solves the problem that we were having, the problem that a site would look horribly squashed if you'd squeeze it into a mobile display. So that's the layout viewport. The visual viewport is basically the part of the page the user is currently seeing, right? Both, by the way, are measured in CSS pixels. I'll get back to that in a bit. So basically, we have the layout viewport, which is used for CSS, and the visual viewport, which is just what the user is seeing. The trick here, of course, is that you can increase or decrease the size of the visual viewport by zooming. Basically, you should see the layout viewport as the canvas of the element. Think of a painting that you're looking through a small hole, right? And you can increase the size of that hole slightly and decrease it slightly, which means that you see part of the painting, and you can move the hole around, but you can never see the entire painting. That's a bit how you have to think about the layout viewport and the visual viewport. The layout viewport is the actual painting, the visual viewport is a little bit that you can see. And you can influence the width and height of the layout viewport a bit, but not too much. When a mobile browser loads a website that is not mobile oriented, what they do usually is zoom out the page as much as possible so that we get roughly this effect. Why do they do that? As far as I can see, this is a UI decision. We want to show the user as much of the site as we can. Of course, it's completely unreadable, but at least the user can say, okay, I'm interested in the main text, or in the navigation, or in the news, or whatever, and then zoom in. So this is what most mobile browsers do with a non-mobile optimized website. Basically, secretly, what's happening here is that I make the visual viewport equal to the layout viewport. Now, I hope you start to understand the whole meaning of the CSS pixels I'm constantly talking about. Basically, you can kind of increase and decrease them until you find a good resolution for you to look at the site. So the page is unreadable, but the user can zoom. Which brings us to zooming. What you have to realize here is that zooming on desktop is completely, totally, utterly different from zooming on mobile. I'm kind of guessing most of you intuitively understand that, but let's dig into it a bit deeper. If you zoom on desktop, you have the browser window, and you zoom in, which basically means that there are less CSS pixels that fit in the browser window, which influences your layout a bit. It kind of depends. If you have a relative width or relative padding left, as we're going to see in the example in a moment, then it kind of tries to keep up with what's happening, but with elements with absolute width are going to grow and shrink. This is, of course, what we want, but it's good to really understand this on a deep level. So, example, this is a site normally, just let's call it zoom 100%. It has meaning on desktop, but it doesn't really have meaning on mobile, as we'll see in a moment. Now I'm going to zoom in, and watch carefully for 2 bits. This is the part that was 34% wide. And this was the element that was 190 pixels wide. Look carefully what's going on. The 34% is still pretty much accurate. There's a bit of zooming going on, of course. A bit of rounding going on, of course. So there is actually a slight difference to where this border is. But this part of the site still takes pretty much 1/3 of the screen, and this part 2/3, because it's a relative unit, obviously. However, this element with 190 pixels starts to grow. And now you can agree or disagree on the exact merits of that growth. Is it a good idea in the design or not? Our designer thought it was, so he did it. But what basically is going on here again is that the CSS pixels themselves have grown, so that 190 of them now take up more of the screen of your computer. Now let's go to mobile. On mobile, zooming basically increases or decreases the size of your visual viewport. Here again, we have the website on mobile, and we're seeing only part of it. If you zoom in, it may appear that the layout changes, but it doesn't really. Nothing is recalculated. right? In the previous example on desktop, we had to start recalculating stuff. Oh, it's padding left 34%. Okay, then the browser has to start recalculating how many actual pixels that are and has to repaint the page. That's pretty expensive on mobile because mobile has slower processors than desktop. Never forget that. If you can avoid a reflow or a repaint in the browser, please do so. In addition, the whole UI concept of zooming is completely different on a mobile device. I'm going to make this switch again. Basically, what we're seeing here is that all the CSS pixels in the entire site are blown up. That also happens on the desktop. But on the desktop, the start and end points are still constrained. On mobile, the site just goes on and on and on. So basically, now it starts to go off the projection screen. And I mean, in theory, you can zoom a lot. I mean, I've done one zoom test where, especially on the iPhone, you could zoom in a lot. I could still zoom in enough so that a font of 1 pixel, just a font size 1 pixel, was still clearly readable. You can zoom and zoom and zoom and zoom. In theory, that means that the site becomes enormous. In practice, what's really happening, of course, is that your CSS pixels are blown up and up and up. So on the desktop, the actual viewport becomes less wide when measured in CSS pixels, right? Because less CSS pixels fit into your screen. And on mobile, it's just a visual viewport, the hole through which you are looking at the painting, that changes, which makes the whole concept of zooming on mobile totally different. And besides, it has the important effect of not forcing the browser to recalculate all kinds of CSS stuff. The visual viewport now contains less CSS pixels. If you look at it from a visual viewport perspective, just from purely the screen and what you see, it now contains less CSS pixels. But the layout viewport does not. I hope you understand this because it's pretty complicated and I'm not totally sure if I'm explaining this the right way. But we'll talk about that during beers. Okay, now some JavaScript properties in order to read out all this kind of stuff. Actually, the situation has improved markedly here. When I started my research about 2 years ago, I did my first research on this. And basically, there were only 3 browsers that really got this right. Namely Safari by Apple, BlackBerry, even the old crappy BlackBerry got this right, and Nokia. Meanwhile, a lot of other browsers have implemented these JavaScript properties properly. We'll get back to a full list later. First, screen.width and screen.height. What does it mean? The width and height of the screen. Duh. But you have to realize that this is in either device pixels on the desktop or in dips on most mobile devices. So basically, what you're seeing here doesn't say very much. Even back in the day when I was only concentrating on the desktop, I could see absolutely no point in reading out the screen size. Why would you want to know that? The thing you want to know is how wide is the user's browser window, because that actually gives you correct context for your website. But I mean, the whole thing of reading out screen widths, I've never understood it. But you can, if you will, and you can also do it on mobile, and even works properly across most mobile browsers. But remember, I'm studying 20 mobile browsers at the time. So if I say most, I mean 18 of the 20 or so, and the 2 remaining ones are very obscure ones. Document element client width and height. This is the width and height of the layout viewport. So basically, without any intervention on the iPhone, it would be 960 pixels wide. And on Android, somewhere between 800 and 1,000. This is measured in CSS pixels because it's the basis of all your CSS calculations, right? If you give a padding left of 34%, it's going to be 34% of the layout viewport. It's kind of useful, mostly because of media queries, which I'm going to talk about later. So let's forget that for the moment. But yeah, this gives useful information. And now we come to the real important part, window.innerWidth and window.innerHeight. This is the width and height of the visual viewport, expressed, of course, in CSS pixels. This gives you vital information, namely how much of your site is the user currently viewing? How much of the stuff can he actually see right now? And I think it's by far the most important properties, not only in this presentation, but maybe even in the entire mobile space, because I think, personally, that zooming is going to be the next big UI thing for mobile websites. We can do so many interesting things with zooming. I've once created an example, and it didn't quite work properly, but it was 2 years ago, and the browsers didn't cooperate, blah, 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 blah. But I tried to make a kind of a newspaper site, and I said, okay, I divide the screen into 4. On the top left, we have the main article. On the top right, we have domestic news, foreign news, sports news, whatever. That quarter of the site that has domestic news is in turn divided into quarters too, which you can zoom into, which contains again a main article and some subsets of domestic news. Same for foreign, same for sports. Basically, you can zoom into the article that you actually want to read. Now, I'm not sure if this is in any way practical. It could be that it's totally unsuited to newspapers, but I still strongly believe that zooming is going to be the next frontier. We have to, we're basically waiting for some totally brilliant flash of inspiration from somebody who's totally unknown right now, and who says, yeah, we're going to work with zooming and we're going to do this brilliant thing with it. And everybody will see it and say, wow, yeah, you're right. So basically, that's why I'm working on the technical infrastructure right now. Once that person comes along with this brilliant idea, I want everybody to be able to read out the zoom level in all mobile browsers. I might be wrong here. It's just a theory, but I hope you will continue thinking about it. Document element offset width and height. It gives the width and height of the HTML element. The width is, of course, usually the same as the width of the layout viewport, right? Because the layout viewport constrains the HTML element. The height may be a lot longer, though, because an HTML page may scroll and scroll and scroll forever. This too is expressed in CSS pixels, and it's occasionally useful. I haven't really found a killer use case for it, but occasionally it can be handy to figure out basically how big your page is becoming. It would be interesting mostly for statistics and analytics. For instance, you want to prevent your user from scrolling too much on a page, and then you can read out how much the users actually have to scroll on that page. And then you have to send that information back to the server, do something with it. It can be useful. Finally, window.page X and Y offset. This is basically the current scrolling offset of the page. This works exactly the same as on desktop. On desktop, you can use these two properties too, and they simply work in mobile browsers. By the way, all this information is on my site, so you don't have to write down everything. You can just go to the viewport section of my site. Scrolling offset is in CSS pixels, and it's useful. So as I said, as far as I'm concerned, this system was pioneered by Nokia and BlackBerry, because back in the day when does anybody remember the old BlackBerry browsers, OS 5 or lower? Yeah. Oh, there are not too many. Good. The other ones of you've missed absolutely nothing. It was the most lousy browser ever. It had a so-called proprietary rendering engine, and in the mobile space, proprietary rendering engine is code for crap rendering engine. But even that old browser got this right, because even the engineers of that old crap browser saw that zooming was going to be tremendously important. So did the Nokia browser. The old Nokia Symbian browser was a bit better than the BlackBerry browser, not really good, but a bit better. And here too, the Nokia engineers decided on this system. I'm not sure how much they were influenced by each other, but I am reasonably sure that they both influenced Apple, because the iPhone does exactly the same, does it right. The other platforms were a bit slow on the uptake. Android really supported this only from version 3 onwards. Android is a problem in the mobile browser sphere in any case. I'm not sure if there are any hardcore fans, hardcore Android fans in the audience. If you are, you might want to cover your ears now. Because you're not going to like what I'm going to say. Android has a huge fragmentation problem. That's nothing new, but it's going to get even worse in the near future. Okay, a little side story about Android. What is a fundamental problem we're seeing right now in Android? Early on, Google said, okay, we've got this free operating system. We want people to have phones in their pocket that use that free operating system because they basically wanted to sell that consumers' information to their clients, right? If you're not, what is it? If you don't pay for it, you are the product. So Google wanted to push it out, and so they basically gave it away. Samsung, HTC, Motorola, LG, the minor ones, etc. And they did all kinds of crazy stuff with it. I mean, in the early days, I did some testing of various Android devices next to each other, and what I found was that all the Android vendors changed the browser a little bit. Why? Because they could. And that's important. You may laugh about it, but that's actually very important for both device vendors and carriers. I'm in the US, I should say carriers. Device vendors and carriers want to be distinguished from the other device vendors and carriers. Samsung wants its UI to be better than HTC's, and HTC wants its UI to be better than Samsung's, right? So they are going to change stuff. In theory, that could be great, you know, some competition, and in the end, one UI will win. In practice, it doesn't work that way. In practice, excuse me, in practice, both native and web developers get totally crazy because they have too many different kinds of devices to support, and especially HTC. I mean, at a certain point, I just stopped following all the stuff that HTC brought out into the market because there were too many devices out there. So fragmentation, fragmentation, fragmentation. What was Google's basic reply to this? Okay, we're going to be more strict. From Android 3 onwards, we are going to be far more strict in how you have to implement the hardware and especially the UI. I remember how surprised I was about a year ago. Came into this company and we were going to swap some devices. And they said, yeah, we've got 2 Android 3 tablets here. I thought, oh, cool, give me. A Samsung and can't remember the other one. Doesn't matter, they were completely the same. UI was the same, the hardware was nearly the same. The only difference was the home screen, because the one had some Samsung apps and the other had some apps from the other guy. Now, this may seem great to you developers. It's certainly great for Google, and consumers could conceivably like it too, but it's absolutely disastrous for the device vendors and for the carriers, because they are not distinguished from each other anymore, right? If the Samsung Android tablet is exactly the same as the HTC Android tablets, why should I care which one I buy? That's what Samsung and HTC absolutely do not want, because they want to be remembered by the consumer as a good brand, right? I mean, it goes way beyond sales. Their whole brand image is in danger here. The whole device market is in danger of becoming commoditized. It doesn't really matter if you buy an HTC or a Motorola or an LG or whatever. It's all Android. And either you like it or you don't, but still it's all Android. So what we're seeing here is a basic tension between Google developers and possibly consumers on the one hand, and device vendors and carriers on the other hand. And I'm not sure how that tension is going to be resolved. In the end, something will break somewhere. Basically, there are 2 broad options. Either Google relents and say, okay, never mind about UI, here, do whatever you like. Or the device vendors and the carriers are going to move away from Android. Or even worse, they can say, okay, Google doesn't allow us to do as we like, then we're going to branch off our own Android. We take a 2.1 or 2.2, and we're going to fix it a little bit and add some more stuff to it, and then we're going to bring out devices with that. It's already happening in China. The Chinese device vendors, Huawei and ZTE, are already doing this. Amazon is doing it, of course, with the Kindle Fire, and it's only going to become worse in the future. When it comes to Android fragmentation, you ain't seen nothing yet, really. Why did I tell this side story? Well, never mind. Oh yeah, in order to explain that Android supports only from 3 on, which is another problem I have with Android. I'm sorry, I have to vent now. Another problem I'm having with Android is that they don't care about the web. Evidence, the browser. Who's here worked with the Android browser extensively? Not too many, okay. And who of you liked it? Exactly. That's what I mean. As far as I can see, the Android browser is starved of resources, as IE used to be before IE8. Basically, it gets better at a glacial pace, and it goes so slow, and in the next version, some bugs are still not resolved, blah, 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 and it's getting boring. And it is in danger of becoming the biggest mobile browser out there, right? Because Android sales market share is now around 50% in the US. So in theory, if all those people are going to surf, which you aren't going to do, but suppose they did, then you get 50% of your mobile visits will be Android. And mobile visits as a whole are on the rise. So 20% of all your website visits may be Android. Think about that for a moment. It's not what we want. So that's basically to explain why it took Android so very long to support this system. But they do now. And again, I'm not talking about Chrome for Android here, because Chrome people, of course, do care for the web. And I expect to see some improvements once Chrome takes over as the default browser of Android. If it takes over. I'm not totally sure what's going to happen, but I hope it does. IE9 on Windows Phone does not support this entire JavaScript property system. I kind of expect IE10 to support it. Microsoft is in a totally different position than Android. First of all, Microsoft had already made its mistake, right? It's called IE6. And they know that they have to basically change the game. Did you ever wonder, we got IE6, which was a pretty good browser when it came out, but it wasn't updated enough. Then we got IE7, was a bit better, right? I did some tests, and yeah, definitely was better, but it's called a really good browser. Nah. IE8, same story. Yeah, it's a bit better than IE7, it supports this and that and that. Yeah, it's fine, okay, cool, yeah, an update, yeah, sure. And then comes IE9, and it's here. And then comes IE10, and it goes up to the roof, because IE10 is a really good browser, as far as I know. I still have to test the latest preview release, but I'm really liking what I'm seeing here. Why this certain acceleration? Why did Microsoft decide after IE8 that they had to dramatically improve their browser? The answer is because of mobile. It doesn't care. It isn't about desktop anymore. It's about mobile. Microsoft knew that they absolutely had to have a good mobile browser in the user's pocket, or they would be out of the mobile game. And I mean, I'm carrying a Nokia Lumia now as my temporary US phone. It's kind of okay. In the browser, yeah, it's not bad. It's not bad. I've seen much worse mobile browsers, sure, but it's not really good either. So this is what Microsoft is clearly seeing, and they're upping the game drastically, and I expect IE10 to be a significant improvement both on desktop and on mobile over IE9. So that's basically why I expect IE10 to support this stuff. Not supporting it just doesn't make sense. Otherwise, browser compatibility is pretty decent across the major browsers I'm talking about. Huh? Opera gets it right now. Samsung Bada gets it right. You ever heard of the Samsung Dolphin browser? 1, 2, oh, more. Okay, some have. Good. Samsung Dolphin is a pretty decent browser. Actually, as far as I'm concerned, it's the third best mobile browser there is. Best is, of course, Safari. Second best, BlackBerry. Third best, Samsung Dolphin, Opera Mobile. And I mean, these three, BlackBerry, Samsung, and Opera, are kind of the runners-up to Safari now, as far as I'm concerned. Basically, what we're seeing here is Apple up the game. Apple said, yeah, you have to have a good mobile browser nowadays. And some companies took that very seriously, and others, such as Google, such as Android, did not. By the way, we're not talking about mobile browsers here. By the way, I'm going to talk about mobile browsers extensively tomorrow in the workshop. So if you want to hear more, come around. What are we going to do now? Yeah. Document the document element.client width, which is the layout viewport, divided by window.innerWidth, which is the visual viewport. This gives you the current zoom level of the user, provided, of course, that both properties are supported correctly. Point is, you're not interested in the zoom level. I have not really found a reason to be truly interested in the zoom level. Well, maybe for statistics and analytics, yeah, that could be. What you really want to know here is how much of the site the user is currently seeing, right? The size of the hole he's using to look at the painting. So basically you want to know the visual viewport width. Visual viewport width and height are by far the most important things you can read out when it comes to viewports. Okay, let's talk briefly about media queries, and then especially the two most important ones on mobile, width and device width. There are many more, but these are about viewports. Remember, this width is the one you want. Forget about device width. I'm going to explain you, I'm going to explain you why. Now, device width gives the width of the device screen in device pixels. And in fact, on all browsers I tested, and that's quite a few, it's equal to screen.width. But as we saw just now, screen.width is not really important. We do not need to know the width of the screen in device pixels. We don't care. We want to know how wide the browser window is, or alternatively, how wide the visual viewport is. So this is the device width media query on desktop, and it gives you the complete width of your screen, well, whatever. The width media query gives you the width of the viewport in CSS pixels, and now that's a lot more interesting to us. Unfortunately, there are a few zooming problems on desktop, and I am not going to go into them mostly because I haven't studied them well. Back in the day when I did this research, I saw there were problems with basically the viewport in the browser window, especially when you zoom in and out of the site, but I haven't really studied them carefully. So I'm not going to give you details. There are some problems. The width media query is equal to document elements client width. Yes, in all browsers, and I tested quite a few, and I was totally surprised by this. When I started out, I was completely sure that at least one of the 20 browsers I was going to test would fail dramatically, but they didn't. Remember, some browsers make mistakes here. Some browsers just give you a wrong number for the width of the visual, the width of the layout viewport, but they repeat the same error in the media query. So the value is still exactly the same. On desktop, it's this. And this is, of course, the source of what we see now with responsive design. All that you're going to increase and decrease the width of the browser window, and you see the site moving around and changing a bit with breakpoints and stuff like that. The technical foundation is the width media query. Okay, what happens on mobile? On mobile, of course, the actual screen is far smaller than on desktop. When we're talking about device width, well, we don't care. I mean, this is the device width on mobile. Again, in device pixels, or more likely in DIPs, density-independent pixels. Why do you want to know this? You don't. Width. The width of the viewport, what does that mean on mobile with the two viewports? The layout viewport. So basically, we're seeing here that the layout viewport, which is used to lay out your CSS, and especially your percentual widths and stuff like that, the width of that layout viewport is given by the width media query. So I'm saying it again, width is the media query you want. But still, if you look at this picture, that doesn't make sense at all, right? Because you're not interested in this either. You want to create a nice website that nicely fits in the screen of your mobile device, of your user's mobile device. We usually don't care about the width of the layout viewport, except in one case, and I'm sure some of you have seen this coming, the meta viewport. This is the meta viewport. We saw it briefly at the start of the presentation. Look at it again, look at its ugly syntax. Oh my God. I mean, this is much nicer, right? This is what Opera proposed. And as far as I know, the Opera is still the only browser that supports this. I would like this in my CSS. this in my HTML, we have to, we're forced to, because we must use this. This is the key to successful mobile site building. Remember that. This plus with media queries. Okay, so what does it do exactly? Basically, what you're telling the browser to do is to adjust the size of the layout viewport. Without doing this, the layout viewport is somewhere between 800 and 1,000 pixels. That's done to accommodate desktop websites that haven't been optimized for mobile at all. If we did not do that, it would look horrendously ugly on a mobile device. But with this meta viewport, we can tell the browser, okay, I want you to adjust the size of the layout viewport. Then you can give a pixel value here. You can say 380. I am actually saying 380 in one of my tests because 380 is not a natural value in any browser, and I do want to have a test for unnatural values. But other than that, I don't really see the point. What we really need here is device width, which basically means the screen size in dips. It used to mean the screen size in 2 device pixels, but then Retina displays and similar displays came along, and we had to keep that value constant, so they invented density-independent pixels. So basically, first we have this without the meta viewport. You can kind of use this site, right? It's absolutely not impossible, but it's not a nice experience. And with the meta viewport, we finally arrive at our true destination, a responsive mobile website. Of course, what we're doing here is not just using the meta viewport. We use quite a few media queries to restructure our CSS first, right? It's one column now. And the whole left column has disappeared. In fact, we have 2 new links here, and there's a link to the menu, blah, 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 blah. You can do that by means of media queries. You can give extra instructions to the CSS. But those media queries themselves depend on giving the website the correct width. Which correct width? The width that the device vendor thinks is most proper for its website, for its device, and that's important. I think the BlackBerry actually has 320, just like the iPhone. But suppose it were to be 350, then the device width gives you 350, and because BlackBerry has extensively tested this, it would be the proper width for your website to be rendered on a mobile device. So it gives you, this gives you exactly what you want. And remember, device vendors cannot afford to make mistakes here, right? If they do, their whole experience of their mobile browser is going to fail miserably, and they don't want that because they understand they need a good mobile browser. As far as I'm concerned, there's little reason to use other values than device width. Maybe we'll come up with a few in the future, but right now I'm not seeing any. Just use device width. And the trick is, you now basically tell the layout viewport to become as wide as the device, and the width media query, which uses the layout viewport, now contains useful information. Basically now the width media query shows us exactly what we want. It shows us how wide is the site going to be on this device. How wide does the device vendor think the site ought to be in order to be shown properly on this device? You can find that information in the width media query. Now in theory, you could say, okay, well, but we can also use device width here, right? Because it gives exactly the same measurement. It's kind of true-ish, but only when the zoom level is 100%. And this is complicated. First of all, we have the difference between actual device pixels and dips. We have some zooming related issues, and basically my advice is not to go there and to use width instead and forget about device width. We are not interested in physical pixels. That's a thing you have to remember. We are only interested in CSS pixels. We want to know how many CSS pixels fit on that screen. We want to know how many CSS pixels are left when the user has zoomed in. That's the stuff we need to know. So I'm going to give you the trick. Meta viewport, again, width equals device width in combination with media queries. I'm kind of guessing you already knew that. For whom is this completely new? A few, most of you knew that. I hope you understand why this is the case. That's basically what I came here to talk about. I want to give you a further understanding of what's going on in this space. And again, I admit this is complicated stuff. I hope I explained it well enough. If you don't understand it, it's probably my fault and not yours, because I'm not 100% sure yet how I should explain this complicated stuff. Anyway, we've reached the end of my presentation. Oh, I've talked for about an hour, that's good. I will put these slides online, I hope tomorrow or something, and you can find them on coursemo.org and PPK on Twitter. Thank you for your attention.
So I'm very concerned about web accessibility. And one of the things that we see very often to address certain accessibility needs is putting content off screen using CSS, negative margins and whatnot. And we're having issues with that in mobile browsers, and I was wondering if you could comment on that.
What kind of issues? Basically that they're invisible.
No, that they're showing up.
That they're showing up.
Yeah. Not always, but sometimes. It's weird.
I would have to see an example of that.
Okay.
I know, but basically it's with text indent minus 9999 or something. I don't know. Can't tell you. Sorry.
Okay.
Any other questions?
Yeah, could you talk a little bit about with media queries using pixels versus EMs? Because we're seeing behavior that's really odd in Safari that you don't see in Internet Explorer 9 or Firefox, for example, if you use pixels. When you zoom
On
in.
the desktop, you mean?
Right.
Oh, really? I'm not totally sure about the desktop, but the whole idea of EMs, it was launched fairly recently, and I think it's an excellent idea. Basically, the message is, instead of the pixels, use EMs in your media queries, because then you can kind of say, okay, I want my lines to be no longer than 40 to 60 characters, which is basically optimal for legibility. So in principle, I'm all in favor of switching to EMs. I still have to test it in the browsers. I didn't have time yet to test it. But as far as the issues on desktop, do they relate to zooming, the issues? Yes, there are issues with zooming on desktop, yes. I must admit I forgot the details. Basically, what you would expect to happen if you zoom on desktop, right? There's more CSS pixels in the same physical space, and you would expect media queries to react to that. They don't always, but I don't know the details. I'm sorry. This is something I just haven't researched yet.
I have a question about, is there a number of pixels different if the orientation of the phone is?
Yeah, on the iPhone, you mean?
On the iPhone,
yes.
yeah.
On the iPhone, this is 320. Device pixels or dips, doesn't matter. Theoretically, if you did this, you would expect the screen width to change to 480. It doesn't. In most other older devices, it does change properly. So, right, if you do this, the official width of the screen remains 320 pixels. Now, first of all, I'm totally sure that Apple did this deliberately. I can't even think of a few reasons why. Because consider, suppose it would switch from 320 to 480. Then it would mean that your entire CSS would have to be recomputed and recalculated, right? The padding left 34% is now going to mean a different amount of CSS pixels. And that's costly in terms of device performance. And Apple Apple and performance, that is really a match made in heaven. Apple absolutely wants to protect users from basically battery drain. Every single time you switch orientation, if you have to recalculate all that stuff, it basically means that the browser has to do some pretty costly reflowing, repainting, recalculating, etc. That's one. The second reason I'm seeing is that the effect can be quite ugly, because you do basically this, and then you see the whole website suddenly changing. And from a pure UI and graphic design perspective, that's quite ugly. So as far as I can see, those are the two reasons that Apple said, no, we're going to be very strict in that, and we're going to change. We're going to keep, even in landscape mode, we're going to say it's officially 320 pixels wide. It's density independent pixels, right? So you can do whatever you want. More worryingly is that in recent devices, I see other device vendors doing the same. Now, as to solutions, we have the orientation media query, which is basically portrait or landscape, which can help you, but it's not supported by all browsers. There are maybe a few other tricks that you could use. On the iPhone, and only on the iPhone, reading out the outer width, window.outer width helps. But I haven't figured out, I mean, it doesn't do anything in any other browser. You should have to be absolutely certain that you're actually on an iPhone. So the problem is solvable in theory, but we should wonder whether we should. First of all, it's technically quite complex to solve it. And secondly, there is a reason Apple did all this. I mean, there are some very weird things going on in mobile Safari, but as far as I'm concerned, Apple has made a deliberate choice to do that. For instance, event bubbling, right? Who here knows what event bubbling is? A lot. Okay, if you don't know, ask your neighbor. Basically, I have, let's say that we have a complete web page here, and this line is a paragraph. I click on that paragraph, and then the browser starts to search, okay, is there a click event on this paragraph? And after that, it goes on to the body and to the HTML element and to the document. And at each level, it looks, okay, is there a click event involved here? And if so, I execute it. That's normal event handling, has been supported ever since IE4. Now, on mobile Safari, that event bubbling doesn't go up further than the body. It does not reach the HTML element, it does not reach the document. I have no clue why. I don't know, and I hate that, right? I'm the guy who's supposed to solve the browser bugs. And I have to say, yeah, I'm sorry, I don't know. I do know how to solve it, and this is totally weird. One way of solving it is setting an empty, an on-click event handler on the paragraph, and that event handler may be empty. So just an empty function as a click event handler on the paragraph, and it bubbles up correctly to the document. The other solution is weirder, much, much weirder. In fact, it's the most weird solution I've ever encountered in my long and checkered career. You set cursor pointer on the paragraph. In CSS, yes, it's that, the mouse cursor becomes a pointer. Is there a mouse cursor in mobile Safari? No, there isn't. But still, if you set cursor pointer, then the event bubbles up. I mean, wow. I didn't figure out that myself. Somebody actually had to tell me, because it would never occur to me to try to use CSS to solve a JavaScript problem. And again, I don't know why Apple did that, and I hate it. I am still kind of hoping that at some date somebody will let me know. But these are the kind of weird things we see in Safari, and I'm absolutely convinced that they are there on purpose, probably related to performance and battery life. I think we're done.